Okay, so in this video, we will discuss work and heat transfer. So this is very important, and we actually need some clear understanding of work and heat transfer. So at the very beginning, let's say what is heat or what is heat transfer, right? So what is heat or heat transfer? Actually, heat is you can say it is a kind of form of energy, just one form of energy. So heat is one form of energy. In other word, we can say actually heat is related to the temperature. We can say heat it is, if we define heat is equal q, we can say it is actually function of temperature. So heat is related to the temperature. If the temperature is higher, then heat will be higher. If the temperature is lower, then the heat will be lower. So that's general thing. We will discuss actually how this heat and the work transfer happen to the system and from the system. So if we think a system is like this, let's say this is a system, just for an example. So we say this is a system, and here we have surroundings. Okay, so this is our system and surroundings. So heat and the work transfer, the interactions between the system and the surroundings happen in two ways. One is the heat transfer, other one is the work transfer. So heat can go from system to the surroundings, that's the one way, and the other way is from surroundings to the system. So this is two cases that we can say this is heat. We define heat equal Q. Okay, let's say it is Q. So the heat could go from system to the surroundings or surrounding to the system. Similarly, work, it could go or it could transfer from the system to the surroundings or from surroundings to the system. So we'll say this is work and this is heat. Right. So that's the way how the system interact with the surroundings, and all of these interactions, it happens in this boundary. So all the heat and work transfer and the interactions between these two, system and surrounding, happens at the boundary. So now, and this is the only way how system interact with the surroundings. So if we consider, let's think about the heat at the very beginning. Okay, so let's think about the heat, how heat transfer happen. And said earlier, heat is kind of energy, just form of energy. So in reality, so we can say heat is low efficient, or in other words, we can say it is a low grade energy. You know what I said? I said heat is low efficient or low grade energy. What it actually means? This term efficient or the grade, it means I just actually wanted to tell you the how the heat convert into the other form of energy. Let's say how it convert into the work. So if we define heat is Q and the work is W, then we can say we said heat is low grade energy. That means we will never get 100% heat into 100% energy. So that means if we supply 100% heat into a system, we will never get 100% work. So if we say we have 50 joule heat we supplied, so maybe we'll get 30 joule of work. So that means it is not 100% efficient. So we can say the heat, it is always greater than the quantity of heat, it is always greater than the work. So that's why we say it is a low grade energy. So which means when you are supplying some heat into the system, you are not getting 100% work. So if you want to get 100%, then what will happen? Some energy it will store here in the system, and this is actually called the internal energy. The internal energy. So what I said, we have supplied we have supplied 50 joule heat, we got 30 joule work. That means we have 20 joule energy in the system. So it is actually the internal energy. So if we want to drive this expression, we need to write it like this: Q equal W plus the internal energy. Internal energy. It is U. So that's actually the thing, how heat transfer is happening from system and surroundings. But the important thing, what I said so far, okay, that's okay. But the important thing for system and surrounding is, let me draw another one here. So we said this is system and this is surrounding. So for heat, two cases could happen. One is from the system and another is from surroundings to the system. We need to know actually the sign convention of this heat transfer from system and surrounding. This is very important. So one case it will be positive, one case it will be negative. Look, when the energy or heat is going from surrounding to the system, that means your system will gain more energy. So when the surroundings is providing energy to the system, that means system is getting more energy. This is positive because your system will get more energy. This is positive. But if the system transfer energy to the surrounding, that means the energy is decreasing into this system. In this system, that means this will be negative. So you need to keep in mind this sign convention always. So any energy which is transferring from surrounding to the system, this is actually positive. From the system to the surroundings, it is negative. If we now think about the work, so similar thing, when we are applying this energy to the system will convert this energy into work. So let's say this is work. Or if we supply some work to the system, so what will be the sign convention for these cases? We can say work is a high grade energy. So we said for heat it is low grade energy. Work, we can say it is high grade or high efficient energy. Okay, so that means work is W, it can transfer 100% work into the heat. So W equal Q. So if we supply some work to the system, it can convert 100% work into the heat. So that's why it's high efficient or high grade energy than heat. So here the sign convention, okay, so heat actually work actually happens it at the boundary here. So work usually, I said earlier, actually this interaction between system and surrounding happens at the boundary. So this work could happen at the boundary due to the shaft torque, displacement torque, or different types of works. We'll discuss later on. So what will be the sign convention here? When you are when you are transferring the work from system to the surroundings, that means it is positive thing. You are getting so your system providing the work. So when we are getting the work from system to the surroundings, so when it is from the system, it is actually positive. You can remember it's just opposite of the heat. And when you need to provide work to your system, that's not good. So that's actually negative. So sign convention for from surrounding to the system, it will be negative. So you can clearly see this work and this heat, the sign convention is completely different. So that's actually how heat and the work transfer happen in system and surrounding. So we'll solve some problem later on. and then you will get some clear understanding. But from this video, you need to keep in mind, guys, especially the sign convention. So when it will be positive, when it will be negative. So that's really important for heat and work. Yes, so we'll solve some technical problem later on, and it will be more clear then.